Good day, guys. Alright, so in this video, I wanted to introduce to you guys the Kirchhoff's laws. There are two of them, and let's look at what they're called. The first one is called a junction rule. Alright, and let's define the word junction first. Yeah, a junction is a point in the circuit at which three or more wires are connected. Right? So it has to be more than three wires connected. A loop, on the other hand, is when you start somewhere, you start the circuit, you go around a path, and you end at the same place. So that's the key, which is you start and end at the same place. So even if you take a rectangular path, right, as long as you end where you began, it is a loop. All right. So let's look at the first one, the junction rule. It says that the sum of all incoming current into a junction must be equal to the sum of all the outgoing current. Mathematically, we can write that down. The sum of all ingoing current must be equal to the sum of all the outgoing current. Okay, so let's take the same diagram that we had before, which is a junction with three wires. Let's call the ingoing I1 and I2, and then the outgoing to be I3. All right. So here we can apply Kirchhoff's law. So the summation of all the so I1 plus I2 must be equal to all of the current that comes out of that junction. So which is I3. So the application of Kirchhoff's first rule gives you a relationship between all the currents that meets at that junction. Okay. The second rule talks about EMFs or potential drops. So it says that the total EMF is equal to the sum potential drops in a closed loop network. All right, so let's just write that down first. The summation of all EMF must be equal to the sum of the potential drop in a closed loop network. So the most basic of all circuits that you can design would be a dry cell connected to a resistor, right? And say the power supply or the dry cell gives out epsilon, right? And the resistor has a resistance of R, right? Which means that you will have a voltage drop of V, and you can measure this by connecting a voltmeter parallel to that resistor. What you will find is the EMF will be equal to the voltage drop or the reading of the voltmeter. Okay, now if we add another resistor, so say you have a different diagram, all right, so you have a different diagram, you have the first resistor and then the second resistor, just like that, all right, and let's call this to be epsilon 1, right, and then you have R1 and R2. Now, because they say that it is the sum of the potential drops, you will have to take the sum of all the potential drops between R1 and R2. All right. So that means I can again apply Kirchhoff's loop rule, and I will have epsilon 1 equals to the voltage drop in the first resistor plus the voltage drop in the second resistor. Applying it in this way will be very different if you have EMFs that has different polarities. With that said, there is a importance in which how you arrange your batteries. I'll cover that in the next video. So see you then.